Welcome to the meeting about the book AI Snake Oil, authored by Sayash Kapoor and Arvind Narayanan. Sayash is a computer science PhD candidate at Princeton University Center for Information Technology Policy. His research focuses on the societal impact of AI. He previously worked in academia and in industry in Facebook, Columbia University, and Swiss Federal Institute of Technology. He is the recipient of the best paper at ACM Fairness, Accountability, and Transparency Conference, and also the Impact Award at ACM CSCW. And last but not least, both authors are listed in Times Magazine Most Influential 100 People in AI. What I value most about his book is how they combine deep sociological and technological knowledge to discern between different types of AI, like between generative and predictive AI, pointing out to their different characteristics. They highlight also fundamental limitations to our cognitions. For example, for predictive AI, it is not possible to predict human behavior because many variables are just unknown to us, and also there is innate randomness of the world. They also point out in AGI safety risk assessment for policymakers, how much this is, how much we cannot do it any accurately, because both inductive, deductive, and subjective probability reasoning cannot be done properly in case of AGI doom. Contrary to many popular voices which treat generative AI as something completely different, they treat it like as a technology like the previous one, maybe that much important as the internet, but they point out to marginal risks and benefits, not only how the technology can act on itself, but how much difference it makes comparing to the existing technologies. And also, instead of following the AI image in the movies, they offer refreshing clarity, showing what it really can and can't do. So, without further ado, let's start the presentation. The presentation will be shared on YouTube, and after presentation there will be a Q&A session which will be shared only internally. Okay.
Awesome. Yeah, thank you so much, Jan. Thank you so much for being here, to those of you in person and those of you online. I wanted to go over, in maybe the next 45 to 50 minutes or so, a brief overview of what I mean when I say AI snake oil, what that does and does not encompass. And perhaps because we're at Google today, I wanted to start by sort of going back 150 years to talk about what specific applications of AI we think are snake oil. The title of the book is not AI is snake oil. It's rather what types of AI are more likely to be snake oil and how to prepare for them. And I want to start around 150 years ago or so, when across the US and in some parts of the world, snake oil vendors were rampant. So they went from city to city selling these snake oil liniments, in this case, Clark Stanley's snake oil liniment, that claimed to cure liver diseases, that claimed to cure back pains, rheumatism, you name it, they could cure it. And the FDA, the Food and Drugs Administration in the United States, was established in part in response to these claims about AI, about snake oil being able to solve everything. And I think we're in a similar position today, to the extent that while we have made genuine and rapid advances in many types of AI, we also are seeing the rampant hype around some types of AI that do not, and perhaps can never work. And that's the sort of AI that we call snake oil. And in fact, if we look back to the historical analogy, the creation of the Food and Drugs Administration and our distinctions between the sorts of drugs that work and those that don't was actually fundamental to improving the state of medicine. It wasn't a hindrance, but rather it was necessary in some sense to get to a place where consumers and the people who most need these drugs can rely on them. So this is an example at the outset of what I mean when I say AI snake oil. So this is an example of a real screenshot of a marketing materials from an hiring automation company. This company claims to predict which job candidates would do best at the job based on just a 30-second video interview. And this video interview is not even the candidate talking about their qualifications or answering questions about what's on the job. This is mostly about people talking about their hobbies, about themselves, what they like in life, and so on. And based on this 30-second video, the company creates something like this. This candidate is marked as assertive. They have a score of 8.98, love the 2 decimal points of precision. And they're marked as being a change maker and so on. And on this basis, they are sort of either move on to the next state of a job, or they're rejected without a human ever having taken a look at their CVs. Companies that do largely similar stuff have collectively raised over $1 billion in funding, and they're being used to automate the first stages of hiring in many, many different companies. I don't know what the state is at Google, but across Fortune 500 companies, the large majority of them use some tool that does hiring automation. Some of them might not be as outrageous as this one, but I do get the sense that this type of tool is really appealing to those in power over hiring outcomes. And this is the type of application that we mean to call AI snake oil. We've looked at the evidence behind these tools. It was very easy because there is none. There are largely no peer-reviewed studies that have validated how well these tools work. And to the best of our understanding, this number 8.98 might as well have just come out of an elaborate random number generator. And so this is sort of at the crux of what makes it really hard for the lay people to understand when to use AI and when not to. And I think one of the single most confusing things about AI, especially in the public, is that AI is an umbrella term. It refers to multiple different types of technologies, many of which have nothing to do with the technologies that have seen rapid advances in the last decade or so. So on the one hand, we have generative AI technologies that have indeed made rapid and groundbreaking progress. We've seen AlphaFold win the Nobel Prize. We've seen DALL-E being used across the industry for creating images based on text descriptions. And on the other hand, we have technologies like Predictive AI. These are tools that claim to predict people's futures, and on that basis, make accurate or efficient or fair decisions about them. Another example of a hiring automation company is something called HireVue. If you look at the materials for how HireVue judges which candidates are likely to perform well in their job, it's by asking questions like, do you like to keep your desk neat or untidy? And this is supposedly a predictor of how well someone works at their job. Now, in the book, we also talk about 2 other types of AI. One is social media algorithms, and the other is robotics. On social media, we go over algorithms used for engagement, but also the ones used for moderating content online. And we point out that while AI is extremely useful for some parts of content moderation, for example, if you have like a large corpus of policy violating images or hate speech, AI can indeed automate that part. But in some sense, that's the easy part of content moderation. The hard part, in contrast, is deciding what the values are, what the boundaries of acceptable speech are, what you expect to allow on your platform versus what you don't. And we think, at least as of right now, AI has very little role to play in the hard part of content moderation, while still being extremely useful for the easy part of automating these policies at scale. And finally, we briefly touch upon robotics, in particular on self-driving cars, but also extremely sort of useful and benign applications like house robot vacuum cleaners. And here we point out that while progress has been slower, so for instance, for self-driving cars, we've seen decades-long predictions that say self-driving cars are just around the corner. We don't see the limitations to this technology as inevitable. Still, of course, there is a lot of role to play in terms of regulating them, and progress might still be longer or slower than we expect. But ultimately, this is fundamentally different from the type of technologies that companies are selling when it comes to predictive AI. So here's another example of a predictive AI system. one of the issues with studying such systems is that most of the companies that sell these tools claim that their tools are private or intellectual property. So unlike generative AI tools, which anyone can use on their smartphones, you basically never really have access to what is going on underneath the hood of hiring automation technology or a predictive technology in other domains like criminal justice or education or insurance. One sort of case where we actually do have some evidence comes from Europe, which is a company called Retorio that, similar to HireView, claims to identify and drive winning behaviors using AI-powered video simulations. A group of investigative journalists did get access to the tool, and they were able to play around with it for a while. And what they found was kind of astonishing and somewhat worrying. So they used two videos that were completely identical. It's the same exact video, except in one case, the applicant, instead of having a plain background, has a bookshelf in the background. And just changing the background basically doubles this candidate's score. So with the bookshelf, they score higher on all the positive metrics. They are much more likely to be hired for the job. And this has not changed any of the substance of this interview at all. This is the same exact video. And I think in some sense, this is understandable. Like, it might indeed be the case that job applicants who had bookshelves in the background for past interviews went on to do better compared to job applicants who did not have bookshelves. But for any individual candidate, this correlation is basically meaningless. So as long as these companies continue to rely on these type of correlations to make decisions about whom to hire, we'll continue to see this type of issue.
So humans are, of course, susceptible to this kind of bias as well. It's known, right? There's examples, scores of examples of people hired for Symphony, whether they were wearing heels or not, and things of that sort, right? So why is this compared this way? It should be compared to what humans do.
That's a fantastic question. So the question from the audience is, humans have similar biases as well. We've known for the longest time. Why should we hold AI to a higher standard? I think to some extent, it's because humans have some amount of scrutability. So they're accountable for the decisions. And, of course, there's a long way to go for improving human decisions as well. But for AI, these things are happening with the black box algorithm that the companies are not accountable for. So the companies are selling this tool. They're not validating the accuracy. If something goes wrong, they're not responsible for it. So I do think there should be like a slightly higher standard. And I think when it comes to deceptive claims by the companies, the FTC, for example, might hold them to a higher standard as well, because they're claiming to sell tools that are fair, that are unbiased, that actually predict who will do better at the job compared to humans, where we, to some extent, understand the cognitive biases, and we know how to train people, even if imperfectly. And I think, actually, like, this is a great example of where this type of bias, like, a bookshelf in the background, might even seem benign. But actually, this bias translates to all other domains. So if you decrease the brightness of a video, if the candidate appears darker, they're much less likely to get higher scores. If you have candidates who wear turbans, they're much less likely to get a high score. And so I think the issue is not just that there is this bias, but that in some sense, there is no recourse to correct this bias. So the candidate has no way to appeal this decision because the reason they were rejected is never actually exposed to them.
It's not different with the standard interview people.
I mean, maybe or maybe not, but I do think there are mechanisms like laws, for instance, to standardize how interviewers do this. We have like the fair hiring doctrines, like the 4/5 rule, which says that you can't have certain outcomes based on hiring decisions, that algorithms in general are not intended or sort of bypass those existing institutional norms. But anyway, I mean, even for hiring automation, I think this is a system which maybe we can get behind the fact that maybe it's similar in the human setting, maybe it isn't as consequential, maybe you have even a chance to opt out, like you can apply for another job at a company that does not use this. But there are certain decisions where actually candidates have no way to opt out and they have no transparency. So when governments are using predictive AI applications, that's when the people who are subject to these decisions actually have no recourse available whatsoever. They can't just opt in to be governed by a different government. I mean, except if you think about elections, that's something that happens once every few years. And in general, for any given decision, you don't really have that decision-making power. And this is exactly what happened in the Netherlands, where the country deployed an algorithm to detect welfare fraud. And over the next 6 years, so from 2013 to 2019, this algorithm was used to screen all applications for child welfare. And what was found was that I think around 30,000 families were incorrectly asked to pay back money. Some of these families were asked to pay back over $100,000. They were 100,000 euros. They were accused of committing child welfare fraud. And in some cases, these families went bankrupt. So the scale at which these predictive AI applications are involved is also much greater compared to the scale of any human decision-making. Moreover, in the earlier system, when this algorithm wasn't deployed, if a family had concerns about this, they could actually simply go back to the representative from the government and explain the situation, maybe argue about it or whatever. But in this case, there was no such recourse because the algorithm's decisions were presumed to be correct and accurate and fair. And in many of these cases, the underlying cause was just incorrect data entries. So someone had forgotten to tag when they had taken a certain child welfare credit, or if someone forgot to tag or update their files. This was the level at which these errors were occurring. But because there was no recourse available to the candidates or to the subjects, the decision subjects, most of them actually did end up paying this money back. And actually, at this point, the Dutch government is in the process of tracking down every single person who was incorrectly marked by this algorithm, so the thousands of families, and paying back an order of magnitude more money as sort of a response to asking them to pay back money incorrectly. And finally, like over the use of this algorithm, 2 years later, the Dutch prime minister and his entire cabinet resigned. So this scandal did lead to this massive shakeup politically, but by that time, most of the harm had already been done. We're also seeing similar tools being used in the US context, so it's not just outside the US. One of the largest healthcare technology companies is a company known as Epic. So if you've ever interacted with the US healthcare system, it is very likely that your data is present in one of Epic's healthcare records. They have data on over 250 million Americans, and they're using this data to create predictive models on an ongoing basis. One of these models was predicting if a person will get sepsis in a hospital. So sepsis is one of the most dangerous diseases in hospitals. It is one of the leading causes of death in US hospitals. And if you can predict sepsis in advance, that can save lives on a much larger scale. So the later you get to sepsis, the harder it is to treat. And Epic claimed in 2017 that they had an algorithm with an AUC accuracy of around 80%. So on this basis, they deployed this model in hundreds of US hospitals, many large hospital systems. And perhaps most concerningly, they did not have any independent validation of the algorithm. So they developed the model in-house, tested it on their own data sets, and then deployed it to hospital systems. It took 4 years until the first study by an independent group came up with an analysis of this model. And they found out that instead of the accuracy being close to 60%, it was close to 80%, it was close to 60%. It was leading to hundreds of false positives daily. So nurses and clinicians were often sent to patients who are doing just fine. And most of the patients that it correctly diagnosed were patients that were had already been diagnosed by the nurses and the doctors. And so it took another year until Epic sort of recognized that this algorithm was flawed and stopped selling this system across these hospital systems. Instead, asked them to create their own algorithms to predict sepsis. And this is the type of failure that is just very hard to diagnose for any single nurse or doctor. So when you're looking at generative AI systems, if you're looking at Gemini or ChatGPT, you can just eyeball the results and tell if something works or doesn't. But if you're a doctor or a nurse at a hospital, you would have had to experience this system hundreds of times to even be able to get a clear sense of what's happening. It's impossible in some sense for a single individual to evaluate how well these tools work. And I think that's in part why it took like 5 years for this independent study to collect enough data to draw this inference and come up with these validations. And I think if we look back at the history of predictive AI, these aren't the only examples. In the last few years, we have seen hundreds of such incidents where algorithms that were flawed were rolled out at large scales to hundreds of thousands of people in areas such as health insurance, disability benefits, legal aid, and so on. And in many of these cases, these algorithms have then been rolled back, simply because they just don't work as well as their developers claim. And I think one of the things we sort of analyze in the book are the many reasons for why these algorithms fail in the first place. An example that comes to mind is a system that was developed in a hospital in the 1990s that used neural networks to predict if someone who came in with symptoms of pneumonia should be kept overnight at the hospital, or if they should be discharged as an outpatient category. And what they found was that the system had exceptionally high accuracy, but that the patients who had asthma were more likely to be sent back home under the system rather than being kept overnight. Now, any healthcare worker knows that if an asthmatic patient comes in with symptoms of pneumonia, they need the highest standard of care. So something was wrong. It turned out that the model was indeed correct in establishing that patients who came in with asthma do indeed have a much lower risk compared to the general population. But that was because under the existing system, these patients were not even kept overnight. They were sent straight to the ICU. And so because they were receiving such high standards of care in the existing system, they were predicted as being lower risk. Now, you might think that these doctors were clearly on something, because why wouldn't they recognize this? But when we are using these types of models that ingest hundreds of features about patients, it's really hard to come up with or understand which correlations are spurious and which one have a causal impact. And I think this is the danger with predictive AI systems, is they are being deployed in settings that are very far away from where they are developed. They're sold as these one-size-fits-all tools by developers who don't really understand what the setting in which they'll be deployed are. And so it's almost impossible to uncover which features might lead to such spurious correlations, might lead to the completely incorrect outcome. And it's one of the things that we sort of discuss in the book that leads to predictive AI applications failing. But our broader takeaway is that for this and many other reasons, while this type of AI can indeed be used to understand aggregates or understand collectives or even predict the weather, understanding the future of individual people and what impact an intervention will have on them is much harder than this type of analytics work, which only focuses on predictions. It's not enough to focus on predictions when we're trying to use those predictions to make decisions about people. Okay, so I don't want to give the sense that the book is an anti-technology screed. It is very much not. This is just our disdain for predictive AI. In fact, there's a humorous definition of AI that goes, AI is whatever hasn't been done yet. And actually, I think there is some truth to this, in the sense that once things start working reliably and perfectly well, robustly enough to deploy in the real world, it sort of fades away into the background. We stop calling it AI. So we have a lot of examples of things that are technically AI. They're using patterns from data that we don't really call AI because they work pretty well, and they've sort of faded away into the background. This is the type of AI we want a lot more of. And our prediction is that, just like we consider spell check a mostly solved problem today, whereas it was an AI problem back in the 1970s, so will a lot of applications that we today think of as AI one day fade into the background. And one of the tasks we see the book doing is sort of highlighting which applications we should think about as being one day reliable enough to work and which ones we shouldn't. And we make like a falsifiable prediction, which is things like self-driving cars, much of what we today call AI, will indeed one day fade into the background, will indeed be reliable and robust enough that we'll start depending on it on a regular basis. We'll stop calling it AI. But certain types of predictions, certain types of AI that sort of are making decisions about people's futures based on predictions using past data will never fit this category. They'll never be reliable enough that we sort of take them for granted. Things like criminal risk predictions, predicting whether a student is at high risk of failure and should be dropped out of school. Things like that are inherently hard to predict. And so moving on from predictive AI, so far we've focused on AI applications that don't work and are harmful because they don't work. But there are also applications of AI that we talk about that are harmful both when they work and when they don't. One example that is particularly poignant is face recognition. So face recognition is a technology that has progressed drastically in the last 10 years. 10 years ago, civil society was concerned about risks of biases in face recognition. The latest NIST study showed that we've basically solved bias, especially in the context of clear photos taken in blind backgrounds. And so for a large number of applications, face recognition is almost something we can sort of use reliably. But that does not mean that it does not come with ethical issues. So we've already seen face recognition being used by authoritarian governments to scan minority populations. In fact, we are seeing questionable uses of face recognition even in the US. So the Madison Square Gardens essentially has started deploying face recognition to ban its owners' enemies. So they have face recognition systems that prevent, let's say, lawyers who work for firms that are in a beef with the Madison Square Gardens owners, even if they have nothing to do with the venue itself, even if they have nothing to do with the cases that the owner is involved in. If you're on the list, you're blocked despite having seasons tickets. It doesn't matter who you are. And I think this is an example of face recognition being misused to sort of prevent people from entering public spaces that are privately owned. And I think we're going to continue seeing large applications of face recognition for mass surveillance, which make it extremely dangerous. So to give a rough sense of what else we sort of try to discuss in the book, I think it's helpful to think of a two-dimensional figure. On the x-axis, are applications rated from how benign they are on the left-hand side to how harmful they are on the right. And on the y-axis are applications rated from how well they work, with applications that work perfectly at the bottom or somewhat perfectly, applications that do work, but there is hype around how well they can work in the middle, and perhaps applications that just do not work, that we would call snake oil at the top. And our focus in the book is everything except the bottom left corner. We like to joke that that's because no one wants to read 300 pages on the virtues of autocomplete. But actually, I think one of the main reasons we wanted to focus on applications that we might not necessarily agree with is because those are the ones where societal debate is necessary to think about what sorts of futures we want. For face recognition, I think it is a genuine topic of democratic as to whether we want governments to have the capability to recognize people on the streets from the perspective of identifying missing children, identifying criminals, or whether we want to prevent that for the purpose of civil liberties. This is not something where we have a clear answer, but we do think debate is essential. So coming back to our sort of the place where we started, that AI is an umbrella term. I think it's not just predictive AI and face recognition, where we have seen claims about AI performing better than people might think. Another place, of course, is generative AI. And I presume that's what a lot of people in this group are most excited about. And I think there, too, we have some amount of responsibility when it comes to communicating how well these tools can work. So I'll start with an example that I found particularly hilarious back in 2023, when OpenAI released their GPT-4 series, or just the GPT-4 model at the time. The abstract was interesting, but one of the most interesting parts of the abstract for me was that the GPT-4 model could pass a simulated bar exam among the top 10% of test takers. Now, many people in the media took this to mean that GPT-4 could soon replace lawyers. There were articles written about, are lawyers obsolete? What is the future of the legal profession? But I think what a lot of people did not understand back then was that it's not enough to pass a bar exam to become a lawyer for a language model, because it's not a lawyer's job to answer bar exam questions all day. There is a lot more that goes on within these professions that is just not captured by the benchmarks we have. So it is indeed true that these benchmarks and the performance of these models and benchmarks is exceptional, should be celebrated, but at the same time, we shouldn't sort of give in to the temptation of seeing this as evidence that they'll replace professions entirely. I think one more place where we've seen a lot of interest when it comes to applications of language models is in agents. So I think in the last few months, there has been a sort of a shift from thinking about language models as being the final application of how we use these tools in the real world, to thinking about agents that are sort of compound AI systems built on top of language models in order to deploy these technologies into the real world. And in fact, to some extent, the models that we interact with are already, to some extent, agents. So this is an example of Anthropic's computer execution, where this language model has a small playground where it can write code, render the results of the code, create small applications that live within it. And I think this is an example of where we see the field heading. At the same time, there is a lot of hype about AI agents. Lots of people have sort of equated the progress we've made in language models and agents to the film Her. But at the same time, we've also seen that these models have sort of failed to live up to the expectations that users often have when they're using these tools in the real world. There are two examples on the right. You have the humane pin and the rabbit R1. In the bottom example, this person ordered DoorDash using the rabbit R1, which was delivered to the incorrect address. And I think this is a clear example of where we are failing to see progress within the realm of language agents. If we have an agent that orders food correctly to your house 80% of the time, that is a huge failure. We don't just need these agents to have the capability to order food to your house, but we need them to do so reliably. And I think that's what we are missing when we are coming to the limitations of language agents. Another place where we've seen a lot of interest is in automating scientific research using AI. So Sakana is a startup in Japan, which recently claimed that they have built agents that can automate all of scientific research. They can write the code, run the experiments, read the papers, do whatever it takes. And so we were curious about sort of how well these systems actually perform in the real world. So what we developed, and then we had been for a few months, so what we were developing back then was a benchmark to evaluate a very small part of the scientific process. So this is not even about automating all of science. Leave that aside. Can we just focus on the really simple task of automating the reproducibility of an existing paper? There is no novelty involved. An agent is given access to a paper's code and data, and it then needs to sort of reproduce what the paper does. If such a tool were built, by the way, it would save millions of researcher hours, because anytime you're doing a new project, you need to reproduce previous baselines. If you're verifying a paper's results, you need to reproduce baselines. And many of the papers that we have seen in the real world are basically simply irreproducible, but even doing this investigation takes a long time. And so even this simple task turns out to be extremely hard for language models or for agents. So we basically compared OpenAI's models. We have like a few more in the works already. But what we found was that if you have like these general agents that are sort of doing all sorts of tasks together, things like AutoGPT, the best performing model scores an astounding 6%. It's able to solve 6% of the 300 papers that we have. If we look at task-specific agents, where you modify the agents to do well on a specific task by compromising on their generality, the best performing agent is a little bit better. It's around 22%. But the thing I want to emphasize is that even for this very simple task, that is a small part of all of scientific research, there is a long way to go when it comes to using agents reliably. So I think our communications with the public as a group of technologists and enthusiasts and researchers needs to reflect this reality to some extent.
I'm not sure the upper bound is 100%.
So this is a very interesting question. And I think, yeah, it is indeed like sad that the upper bound should not be like 100% for our research today, because so many papers are reproducible. For this benchmark in particular, we manually reproduced each of the papers in the benchmark. In fact, we did that 3 times so that we had some amount of variance information and only included papers that were indeed reproducible. So you're right. If we looked at the real world, like papers that were not reproducible, this would be even lower.
Well, I mean, just to jump in, I mean, you're saying accuracy, right? So you're not saying if it's false positive or false negative. You could have non-reproducible works also. So I think that's not what was done here, but like accuracy is always up at 100%.
Okay, anyway, for some definition.
Yes, true positives plus true negatives over all.
My point was my wife works in biotech, and they know that something like 70% is what can do at best.
7-0?
70. That's a jam. It's just very
All right. Yeah, thank you. That is helpful, actually. I did not know that statistic.
okay. Don't quote me on the number.
Okay. All right. So I think one of the things that so we also try to do in this book is sort of lay out a map of where we think incorrect information or misleading information about AI comes from. And I think one of the main places is from AI companies. And I don't mean companies that are building like these foundation models, but companies that are using them in whether it is for predictive AI, claiming that AI can sort of automate hiring, or from startups that have claimed to solve agents that can reproduce or create automated science. Another area is in research. And I think as we were discussing just now, there is a challenge when it comes to reproducing research outputs. And in particular, the one challenge that we found over and over again is something called data leakage. When you are evaluating models on data that already has the signal from that they're used to train on, that's what we sort of broadly refer to as leakage. So the most basic example of leakage is something like you have no trained test split. You're basically just evaluating models on the same data you're training on. This is, in some sense, like the textbook example of overfitting, and yet we found in our work that this is surprisingly prevalent. So this is a review by Poldrack et al. Of neuropsychiatry, which found that there's 100 papers that were published in peer-reviewed venues, and 45 of those papers had no test set. So when it comes to machine learning-based science, that is not just AI, but the fields that are using AI, in some sense, the practices are even worse. Another example is using illegitimate features for the task at hand. So for example, in this case, using the fact that a doctor has ordered hypertension medicines for someone to predict if a patient will get hypertension. Now, once again, this seems like a really bizarre example. Why would anyone train a model that uses a hospital's diagnosis to predict if someone would in the future get hypertension? But that is exactly what we found in papers that have claimed to predict if someone will get hypertension. So in this case, this was a paper that was used to develop a model that's used in the US state of Maine, or was used back in 2018. And they found that the 5 of 6 most important features for the model were anti-hypertension drugs. So this is the sort of like leakage that we are seeing over and over again. These are errors. And mind you, I'm not pointing this out to say that the researchers were careless, but that when you're developing these models with hundreds of features, and you're moving from a paradigm of doing statistical research with a few small number of features to large-scale machine learning with hundreds or perhaps thousands of features about a person, this type of error is really easy to make. We should be on the lookout for it. A final example I'll give is Michael Roberts and others at Cambridge did the study of every single paper or study that claimed to diagnose COVID-19 based on chest x-rays of patients. Every single one that was published in the first 18 months of the pandemic. They looked at, I think, around 400 or so studies, and they found that none of these studies were of any clinical utility. In particular, one of the examples of leakage that they found was that all of the patients that they used that were examples, or in some of these studies, all examples of patients with COVID were people who were adults. And all of the examples of patients without COVID were people who were children. So this affected, like, I think, 16 of those studies they looked at. And so essentially, the language model or the AI systems that the studies had built were indeed getting a very high accuracy, but they were highly accurate at telling apart kids' chest x-rays from adults' chest x-rays. They had essentially no utility when it came to predicting COVID-19. So we sort of started collecting all of these examples of where leakage has been found in scientific research that uses ML. And what we found was that over 600 papers in over 30 different fields had been affected by leakage. And perhaps more concerningly, each of these fields is independently rediscovering leakage within their specific discipline. And I think this is not surprising based on the discussion we were just having. I think there have been many concerns that when it comes to adopting machine learning, it worsens the existing state of reproducibility because of these issues. So in magazines such as Science and Nature, Wired, all of these outlets have also sort of come to the realization, to some extent by talking to researchers, that there are these challenges that machine learning poses to the scientific method that are perhaps somewhat distinct from earlier reproducibility issues. And I think one thing that is sort of important to appreciate is that reproducibility failures are, in some sense, harder to detect when it comes to scientific research than for engineering applications. So my hypothesis is that the way scientific research is conducted has something to do with these causes. For engineering, when we're using machine learning, the three phases of like any given project might be: you build a model, you validate it, you deploy it to the public, and once you've deployed it, you have a mechanism for detecting errors, whether it is through dog fooding your product or through actual input from the public. As a result, it's not that, I mean, it is still bad for your product, but it's not that necessary to have this extremely high bar of having flawless products at the time you launch. You can, and companies always do, fix these products in production. In contrast, for science, the first two steps are still the same. You still build these tools and validate these outcomes. But the third step is often to publish a paper. And once a study is published, it is really hard to challenge the results of that study. In some cases, because it's literally impossible to do that, the researchers don't release their code or data. In other cases, because of disciplinary norms. So when we've uncovered reproducibility failures in studies that are like cited by hundreds of other papers, the authors have often failed to acknowledge it. They've sort of come back to us saying this is not an error, even in cases where the authors have trained on the test set. And so I think because of these incentives, it's just very hard to challenge these incorrect claims. And it just makes it like take a much longer time to get to the current state of scientific consensus. In some cases, we've also found that the entire community might believe something that's incorrect based on the results of machine learning-based science, that they're just not willing to change based on reproductions that fail. And so I think this is why, to some degree, you all at Google are sort of in a better position when it comes to reproducibility, because the incentives are somewhat much better aligned compared to the research community. Okay, so this brings us back to this map that I wanted to lay out. So we had companies on here. I didn't want to single you all out, so we'll also put researchers on there. And I think these are the two main sources of a lot of the claims that AI companies or that the public is hearing about AI. And as a result, most of the prominent results that people hear about are exaggerated. Now, on top of this exaggerated results about AI, we also have public figures arguing about what AI will do to the future of existence or the future of humanity. For example, this is a letter that was released in 2023, soon after GPT-4 was released. It was a letter that was signed by many leading luminaries of the field that asked companies to stop training large AI models for the fear of civilizational risks. Now, we've seen this play out over and over again. We have an entire chapter in the book about why some of these claims might be exaggerated. But here I want to point out that one of these signatories was Elon Musk. I think 1 year later, Elon Musk has one of the largest AI training data centers in the world. By some estimates, the GPUs that they have now, 200,000 H100 GPUs, are more than enough to train models that are 10 times larger or like have 10 times more compute than GPT-4 in a matter of months. So it's not just to point out people's hypocrisies, but rather that when AI experts are making claims about something, they're often seen as the leading experts to rely on. But in fact, when it comes to claims outside of AI progress, they actually don't really have that special insight or knowledge, and we shouldn't defer to their claims. Another example of a claim that I wanted to highlight is by recent Nobel Prize winner Geoffrey Hinton, who said in 2016, and I'll quote him on this, "If you work as a radiologist, you're like the coyote that's already over the edge of the cliff and hasn't yet looked down. People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists." So 5 years later, where is deep learning? Well, this is an example of a paper that was published about 5 years later, that found that deep learning for recognizing pneumonia in chest X-ray images was, instead of realizing the patterns that happen in the lungs itself, was looking at the hospital token on the top right side. So almost the entire reason for why it came up with the decision was because it looked at the hospital tokens and not the lungs. At the same time, we also had, 6 years after his comments, a worldwide shortage of radiologists. So in some sense, I want to point out that this is not to single out Hinton or Musk or anyone in particular, but that when AI experts are making claims about the impact of AI on professions, they are basically relying on their intuitions about AI, but they're not the right people to have intuitions about what goes on in these domains. It's almost like when the typewriter was invented, saying that the typewriter will put writers out of work. Just because something can perform the outside function of a particular job is not enough to understand its impact on a profession. Now, I'm not saying that this means that AI will not have an impact on these professions, but just that the experts who we should be relying more on, whose judgment we should be incorporating more of, compared to just deferring to AI experts, are the domain experts, perhaps aided by AI experts in terms of their view of the technology. Okay, so coming back to the map. So we were at the place where most AI results are exaggerated. On top of that, we have public figures who are making tall claims about the future of AI. And all of this together leads to this rampant AI hype in most of the content that the public is seeing. But our journey does not stop here. So one more example that I wanted to quickly share is the set of news headlines that came out after Microsoft released its GPT-4 powered Bing chat. The New York Times said the next day, Bing's AI chat, I want to be alive. The Washington Post said, the new Bing told a reporter it can feel or think things. And this is just like 2 examples out of the dozens that the public was faced with the morning after Microsoft's release. Now, to some extent, this is a known phenomenon. In fact, we've known that when people interact with AI systems, they tend to attribute humanness to those systems for the last 6 decades. So this is an example of a chatbot known as Eliza, developed by Joseph Weizenbaum in 1966. By today's standard, this is the most rudimentary chatbot we've ever seen. It would basically simply parrot back people's responses in the form of a question in something resembling therapy. So Eliza would say something like, is something troubling you? And maybe you would respond, men are all alike. Eliza would just respond with a generic question, something like, what is the connection, do you suppose? And the conversation would go on and on. What we've known, though, from this time itself is what's known as the Eliza effect. People who talked to Eliza would often refuse to believe that they had talked to an AI system, even after being told how the system was created. And I think this is the type of information that is especially responsible or especially useful from the perspective of journalists to hear. But I think to some extent, journalists are doing the opposite job when it comes to AI reporting, is portraying these systems as if they're sentient. Another pet peeve of mine is using images of robots on examples of AI that have nothing to do with robotics. So this is an example from CNN. The system in question, in particular, in this particular article, was closer to Microsoft Excel than the Terminator. It was just a simple number cruncher. And yet, over and over again, we see that when communicating to the public, journalists are relying on this type of image of a humanoid robot or metaphors about sentience or cognition. And I think this is what sort of closes the feedback loop of AI hype. So once you have rampant AI hype that is sort of parroted back to developers, parroted back to the public uncritically by journalists, by sort of relying on our cognitive biases, such as towards anthropomorphizing non-human things or objects, I think that completes the feedback loop of AI hype. And this is how hype persists. Now, some of you might be thinking, why does any of this matter? Like, we are the technologists who are making grounded claims, relying on empirical science, doing good work to advance the future of generative AI systems that do work rather than systems that don't. I think this does still matter, even from the perspective of technologists who are looking to do the right thing. So one of my favorite recent books is this excellent overview of the history of economic revolutions by Jeffrey Ding at George Washington. It's called Technology and the Rise of Great Powers. But I think the one line takeaway from this book is that when we are looking at general purpose technologies, that I think AI certainly is, their impact is realized at the moment of diffusion, when these technologies are diffused across different productive sectors of the economy. It's not enough to create better and better AI systems, but we also have to get professionals to use this technology in their day-to-day work to actually realize the benefits of this type of technology. Unfortunately, the hype that we're sort of creating with this technology so far has led to a case where even professionals such as lawyers are citing fake cases, are being continuously reprimanded over and over again across countries, across jurisdictions. We've seen lawyers turn to AI to generate citations to cases that don't exist. And at this point, I think it's fair to say that generative AI has been a net negative for the legal profession. So if we want to get to a place across settings, not just the legal profession, but in education, in healthcare, in finance, a place where people do know how to use AI well, and not just people who are in tech companies or in the tech world, but rather people in other professions on whom we depend to in some sense, realize the benefits of productivity and improvements of using AI. I think we have to get to a place where people know what the real risks and benefits are. And without doing so, we are leaving a lot of impact on the future. Okay, so this is sort of the end of my talk. I'll briefly go over like what else is in the book. So what I talked about basically covers maybe 2 of the chapters of the book, one on predictive AI and one on how AI hype is created. But we also in the book talk about the 80-year-old history of AI, which we felt was important because for a lot of people outside the tech world, ChatGPT sort of came out of nowhere. It was the first interaction with an AI system. But actually the advances, and on the slide here is Frank Rosenblatt in 1958, showing the basic perceptron system that could recognize characters or figures. We have an entire chapter in the book that is not about AI at all. It's rather about the social processes that we're trying to predict using AI, when they will work, and when, in our view, there are fundamental limitations. So the image on the top shows a weather system from the 1800s. And weather prediction is indeed a place where we've made massive and like constant progress over the last few decades. Some of the most recent work out of Google DeepMind, such as on GraphCast, shows what the potential for AI in predicting the weather is. Compared to that, on the bottom here, we have something known as life outcome prediction. So basically, you try to use children's life outcomes, collect massive amounts of data about what happened to them at certain ages, and try to predict what would happen to them in the future. So one of the best studies that have been done on predicting children's life outcomes was in Princeton, where they found that despite using tens of thousands of features about every single child, despite having access to the data for more than 4,000 people or 4,000 children, the best AI models were no better than a simple regression model that just used 4 features about a kid, 3 of them about their mother, and 1 about a lagged outcome variable. So if you're predicting the GPA, what was the GPA the previous year? And I think there are some fundamental limits that have been uncovered in this type of predictive setting, which sort of make me think, or our position on the book, which inform our position on the book, that some types of life outcomes, some types of social outcomes are inherently unpredictable. As I mentioned before, we also talk about the existential risks from artificial general intelligence, why we think current arguments for the existential risks are unlikely, and why we should still take seriously the possibility that AI safety is an important sort of thing to invest in, especially from the point of view of other catastrophic risks that maybe don't rise to the level of existential risks, such as cybersecurity and bioweapons. Some of my favorite work on cybersecurity is actually out of Google, where I think the company is using LLMs to detect bugs and vulnerabilities in open source software. And based on those vulnerabilities, they're sort of informing the defenders. So I think there are many ways we can use AI to reduce catastrophic risks, to reduce the risk of cyber attacks. I think those are worth looking at and investing in. One section of a book is titled Broken AI is Appealing to Broken Institutions. So here we talk about, in this talk, I've talked about where the supply for AI snake oil comes from. But in some sense, that's only half the picture. And in the other half is where is the demand for AI snake oil coming from? And so our hypothesis is that when you have these broken institutions, like the hiring manager who's tasked with sort of screening 1,000 resumes for a single job application or for a single job opening. That is the sort of institution we're thinking about, which can no longer function under the current resource and time constraints. And so if we were to take out AI, if we were to take AI out of the picture completely, these are still institutions that would be looking for a silver bullet. We briefly talk about the myths about regulation, both from the perspective of regulation being a silver bullet that will save us from the harms of AI, and from the perspective that no regulation is the best way forward, because we do think that regulation is essential to protect the public from some of the harms of AI, in particular predictive AI. And finally, we conclude with a positive and negative vision for the future. So we talk about the lives of 2 children that are born on the day ChatGPT was released. What are the visions for how we might go about developing AI, regulating AI, what the 2 possible outcomes we have are, and what our role is as technologists to steer this world towards this positive and away from the negative vision. Okay, so that's everything. We write a blog on aisnakeoil.com. If you want, please do subscribe, and I'll open it up for questions.